Hey there students, it's Miss Adams, and in this video we're going to learn about correlation.
All right, so the correlation is designated by the letter R, and it uses a range of numbers between -1 and 1 that measure the strength and relationship of a linear relationship between two quantitative variables. If R is close to 1 or -1, the model is considered a good fit. If R is close to 0, the model is not a good fit. If R is equal to exactly positive or -1, then the model is a perfect fit with the data points laying on the line. If R equals 0, there is no linear relationship between the two variables. If the relationship is negative, then your R value is going to be less than 0. If the relationship is positive, then the R value is going to be greater than 0. A correlation greater than 0.8 is generally described as strong, whereas a correlation less than 0.5 is generally described as weak. Okay, so there's not super specific rules, but kind of here's what visually they look like. So perfect positive correlation, a strong positive correlation, a weak negative correlation, no correlation, a weak negative correlation, a strong negative correlation, and a perfect negative correlation. So you can kind of see those correlations. It's about how spread out those dots are visually. All right, important to note, a correlation close to 1 or -1 doesn't imply that an association is linear. So just because the correlation is really, like the R value is really close to 1 doesn't necessarily mean it's linear. The scatter plot to the right is clearly nonlinear. You can see like a curvature happening, yet the correlation is R equals 0.93. All right, so correlation does not imply causation. And you want to be careful. We only should be using R, the correlation coefficient, if our data is linear. All right, estimate the correlation coefficient. So we have two scatter plots here. And just kind of looking at the scatter plot, what would you estimate the correlation to? This is going to take a lot of practice to get good at. So you're looking at how spread out those dots are. I'm going to say for this first one, I'm going to estimate R to be, it's going down. So as I look at a graph from left to right, I can see that the points are decreasing. So it's a negative. I'm going to say negative 0.79. And then the other one is going up. It's positive. They look like they're a little bit more tightly packed together than the other green dots. So I'm going to say R is about 0.94. Okay. And interpreting the correlation coefficient. So if they give you the correlation coefficient, what does that tell you? So if R equals 0.98, this tells me that there is a strong positive relationship between X and Y. Remember, R, the correlation coefficient, tells you the strength and the direction. So it's strong because it's really close to 1, and it's a positive value, so it's a positive relationship. The next one, R equals negative 0.21, so it's negative and it's not very close to 1, so it's weak. There is a weak negative relationship between X and Y. And if you knew what X and Y were, you would put those context pieces, like the actual name of the variable there. R equals 0.65, we'd say that's moderately strong. So there is a moderate positive relationship between X and Y.
All right, that's all for now. Thanks for watching. See you next time.